Hi everyone, we're going to identify and graph our polar equation r equals 3 cosine of 2 theta. This is a rose with 4 petals, and we're going to check for symmetry before we start to graph it. There's 3 tests to check, and the first one is to check symmetry with respect to the polar axis, the x-axis. So basically what you do is you take your r equals 3 cosine of 2 to the, instead of theta, we're going to substitute in negative theta. All right, so this is going to equal 3 cosine of negative 2 theta. Since cosine is an even function, this goes away. So basically, we have r equals 3 cosine of 2 theta, which is an equivalent equation to our original. So that means it passes the symmetry test, and our graph will be symmetric with respect to the x-axis. Okay, the next one is the hardest one, and that's see if it's symmetric to the line theta equals pi over 2, which is just the y-axis. So you take your r, 3 times cosine of 2, and then you're going to substitute in your theta with pi minus theta. All right, this is going to give you r equals 3 cosine of 2 pi minus 2 theta. We're going to use our sum and difference, basically our difference formulas for cosine, and expand this. So when you expand this, we're going to get 3 cosine of, let me do it this way, 3, I'll put the bracket here, cosine of 2 pi times cosine of 2 theta plus sine of 2 pi times sine of 2 theta. All right, now sine of 2 pi is 0, so all of this is going to zero out. Cosine of 2 pi is 1, so you get 3 times 1 cosine of 2 theta. Now, since this is equivalent to our original equation, our graph is also symmetric to our y-axis. So it tests positive for both of these. All right. Now for the last one, is it symmetric to the pole? Well, since it's symmetric to our polar axis and our line, then this one's going to be also symmetric. Since they're all symmetric, all we have to do is test values of theta from 0 to pi divided by 2, i.e. the first quadrant, and then we're going to use symmetry to finish the graph. All right, so we're going to have our angle here, and just use the first quadrant as 0, pi divided by 6, pi divided by 3, and pi divided by 2. And we're going to find our r value. Let's write it what it is here and substitute in. And when you substitute in your angle, you're going to get 3 3/2, 0, let's see, I'm missing one. Let's put in 1. I forgot 1. I'm going to go ahead and use pi divided by 4. And then pi divided by 3, pi divided by 2. Sorry about that. So then we'll get negative 3/2, and then negative 3. Usually I don't put this one in, but for this problem it makes it a little better. So let's graph this. At 0 we have 3. So 1, 2, 3. Going out 3. So that means it's also going to go out 3 here, 1, 2, 3. It's all going to be symmetric. 1, 2, 3, and 1, 2, 3. All right, for pi over 6, we are at 1.5. So that's about here, here. Oops. This is at pi over 6, so 1.5. Use all your ones with 6's in them, and go out 1.5. All right, and then we have pi divided by 4, which is this one, and it doesn't connect here, and that one is at 0. So at pi over 4, we're at 0 on all 4 places, and at pi divided by 3, so let's see what we have so far. We're going from here to here, and then here to here. At pi divided by 3, we're at negative 1.5, so you're going down 1. And at pi divided by 2, we're at negative 3. So basically, that is the first half. But all you have to do is use symmetry and substitute everything in. And this is going to go back around. It's like this. And there's your rose with 4 petals. All right. Thank you. Have a nice day. Bye-bye.